Hello and welcome back, and yes, we're continuing talking about PS5 SSD storage. I know it's been a heavy PS5 week here on the channel, but this is an incredibly important subject to a lot of people that are going to end up spending a lot of money, and they have to do it right. And I want to continue talking about heat sinks, because the last few videos I've done in the last few days, in the comments, thank you so much for engaging and clicking like and even dislike if you didn't like it, but one subject has bubbled to the surface which I didn't realise was actually a question. And the question was, do I need a heatsink? And by the way, you do. This video is about telling you that it shouldn't be a yes or no, or should I or shouldn't I not question. Get a heatsink. If you're going to be buying, and this doesn't just apply to PS5 by the way, this applies to anyone in video and photo editing circles, in PC gamers, from the small to the big to the esports, buy a heatsink. And in today's video I'm going to talk about exactly what a heatsink does. I'm going to talk about a heatsink inside this system, about airflow and the things you can and can't do, and of course towards the end of this video I have a demonstration showing you temperature rises with and without a heatsink to show you exactly the difference in sustained activity. That's the key word in today's video, sustained. And if you do want to just see the temperature difference, fast forward to the end of the video, but I do recommend you hang it out till now, because all of this is what we're going to be talking about with regards to individual SSDs, the NAND, the chips, the heatsinks, which ones you should and shouldn't go for, everything. So let's get straight into it. Why should a person use a heatsink for the SSD inside both their PS5 or any kind of gaming console device? Well, these devices work by electricity passing through them and reading chips on board called NAND. But it's more than that. SSDs have a little brain on board called a controller. They've got an area of RAM, a little bit of memory there, in this case DDR4. In the case of this SSD, the Sabrent Rocket 4 Plus, which is PS5 compatible, and on top of that there are those individual chips on board that have got all of your storage. If I remove this top label here, you're able to take a good look at all of those chips there. The ones closest there, these are a couple of bits of NAND. These ones in the middle are the controller and the memory, and there's another block of NAND there on the end. This drive here goes in there and it reads a bunch of user electricity to read zeros and ones off of that NAND to ascertain the storage, both for writing and reading. Now, NVMe SSDs are designed to be operated within the boundaries of 0 to 70 degrees Celsius when in operation. That's when they're at their best. However, when it comes to premium performance, you need to remain between 0 and 50 degrees Celsius. That's their best performance. And the minute you start exceeding 50C, the controller on board will start to throttle the performance a tiny bit. And once it crosses 70 degrees Celsius, it will throttle it even more. Why does it do that? Because the rising temperatures inside can be detrimental to the effect of the device, and indeed the endurance of the device long term. So that's one of the reasons why temperature is so important to SSDs inside any system. Again, when it comes to consoles, when it comes to PCs, it's all the same. You've got to keep within those boundaries. 0 to 70 at all times, but 0 to 50 Celsius if you want good performance. Now, why is that important? Because some activities you do on a console will be very brief. There'll be very small amount of data every now and then. Or there'll be big blocks of sustained constant activity, be they loading screens, be they world building, online, that sort of thing, creation. This is where the heavy sustained activity comes in, and the longer those periods are, the higher the temperatures will go. Now, on an SSD, those little blocks that I talked about, the NAND where the actual data lives, they can be warm, and by warm I mean they can be an alright temperature. They work better when they've got a bit of warmth there, the data flowing. It helps with the utility of the NAND. You don't want it too hot, you just want it warm. But the controller and the memory on board, the CPU and the RAM of this, so to speak, they are at their best when they are coolest. And that's why you will generally find that heat sinks, particularly enterprise ones, stack things heavier at the end of the SSD. We talked about in another video the Aurora 7000S, which has a heatsink that's included, but the best part of the heatsink is directly on top of the controller and the memory. That is the bit where you have to be at its coolest. But ultimately, they're all on the same little board. That means that the temperature still has to be wildly consistent, not inconsistent, consistent across the whole drive when it's in operation. Now, some SSDs have got paper little stickers that people will wonder, should I remove that sticker? To be perfectly honest, given the power of these SSDs and the performance they go at, this little sticker makes almost no difference. It's about doing greater things than that. And sometimes removing the sticker will actually void your warranty. So I would not recommend removing stickers in modern SSDs. Now, other SSDs, like the Sabrent Rocket 4 Plus, actually have a metal sticker there on the top that actually aids heat dissipation, which is another reason not to remove it. However, that is still by no means enough to withstand sustained performance. So I would still recommend in all other instances to never remove the labels on an SSD, both for warranty purposes and because of it having little to no difference overall. Now, if we flick over to my PlayStation here and we remove the lid very quickly and we have a quick look, we can see, as I've done this a million times this week, there is our M.2 NVMe slot there. We've got this lovely two-way fan that they've built into it that both draws and pushes air to create a kind of forced bubble inside that sealed block there on the bottom. And if I remove the panel there at the top, we can talk a little bit about the slot itself on this console and how different heat sinks are going to be factors there for you. So if I remove that little metal cover, and we will talk about that, we can have a look at the slot itself. Now you can see that there on camera. Little green bit there, little holes there for different length SSDs, and a connector there at the top. Now surrounding that bay, you can see those little metal kind of gauges, those side bits there. They are kind of heat absorption panels, but they don't do a vast amount in the grand scheme of things on ensuring the cooling of an SSD. There are tiny little airflows all the way through there, but ultimately the bulk of heat dissipation is not going to be coming from there. It's going to come from heat sinks. Now, the reason it's been a big song and dance about heatsinks on PS5 and these new SSDs that we're getting support of in the beta and very, very soon in the full rolled out software update is because some heatsinks do not fit in there. So if we look at this slot here, and I'll take this, well, this is a heatsink I've talked about a lot on the channel previously. This is the Elegant. Now this one, you put the SSD inside. This fits in there. Great. It goes in, the panel on the top fits on. It fits perfectly with an SSD inside there, be it double or single-sided NVMe's inside there, which is absolutely great. But some heatsinks, more expensive and definitely better performing heatsinks, and again, this is another Sabrent Rocket Plus heatsink that we talked about before, this is quite large, and if you put it inside there is no way that panel is fitting on, as you can see. Now, in this scenario, I can tell you that I personally would use this console without that metal panel on there. A lot of the kind of closed cooling on this system applies to there, and the active airflow over those vents that surround the system. But what's particularly interesting is even with that big chunky heatsink on there, the casing fits on perfectly. That fits in there perfectly, and that heatsink isn't touching, it's not touching the top of the panel there, and it allows air to pass around that heatsink, and I do not think it will be detrimental to the system. Obviously, we should check until the official compatibility listing come out there, but me personally, I'm going to use a bigger heatsink than these. This is still a very good heatsink, and I do recommend it for use inside this system if you want to play it quite safe and you still want plenty of cooling. So that this panel here at the top, let's remove it from there, get that out, can dissipate heat from that SSD, and all the heat from the SSD and the NAND goes into that, and then it disperses it equally, drawing it from the SSD inside there. However, a lot of people, you know, they're not going to be as keen on utilizing these big chunky heat sinks, and I get that, I really do. However, don't go the other way and go for heat sinks like this. I mentioned this in my previous video. This is a heatsink that uses bands. You see these bands here? What it does is you take this heatsink and you get one of your little thermal panels, you bung that underneath like so, it's incredibly thin. You get your NVMe, you place it on it like so, like that, and you put the bands around it. You get your band, you stick it around it, you get another band, you poke it on. Doing this rushing for camera is never good. And that is how your SSD looks inside there. It's the SSD, it's got a little heatsink and it's got those bands. However, do not use these, okay? Few reasons. First and foremost, because sometimes you're going to get dual rank SSDs, and it can be beneficial to make sure you've got additional heat dissipation on the base of this SSD. But also, some of the cheaper versions of this use very cheap bands. This is £5, this little cover here. £5 I paid for that. And that £5 I paid for that has got these rubber bands, which are incredibly thin. I'm not 100% certain that these silicone or rubber bands are going to withstand sustained temperatures inside this. And the last thing you need is not only these drying out and snapping and potentially falling loose in your system, but also them actually adding heat block to the assisted airflow coming off the heatsink as it dissipates the heat. So make sure you avoid these weird little silicone rubber band heatsinks and go for contained metal heatsinks all the way through that will close in. Whether you're going to go for a heatsink that fits inside that slot or a chunky one that you remove this metal panel for and get the assisted heat dissipation all the way through. So I think I've told you enough about heatsinks right now that you want to see the demonstration. You want to see what is the actual real world difference. So we're going to move over to my test machine where I've taken a Samsung 980 Pro. I've gone for a very small capacity as well at 250 gigabytes just to keep it as base as standard. I'm using OBS to screen record it, and I've done 2 instances 10 minutes apart, letting the system and the SSD cool down, and I've done sustained activity for 5 minutes. We're going to voice over it and go through exactly the difference in real time. But before we do it, again, I'm going to mention it in the video just to remind you, but this is not about measuring the read and write performance. They are going to be very, very bad in this test. I'm doing constant sustained activity, and this is constant sustained micro activity of smaller files, and I'm running OBS, which is a capture recording software which already can tax the system and utilize the media inside. So when watching this, focus on the temperature. Do not focus on the read and write. Maybe just on the disparity or how they dip over time, but don't go and look at it and go, oh my God, it's not hitting anywhere near the speeds it should. That is not the purpose of that video, but make your way over to the test vid. Right, so you can see here on the screen, we've got the Samsung 980 Pro inside the test machine. These are 2 instances. On the left-hand side, we've got that Samsung 980 Pro with a heatsink, and on the right-hand side of the screen, without the heatsink. I managed to get the temperatures pretty close internally at 38 and 39 C, so I think we're absolutely fine there. And we're going to do some sustained tests. Now, a few disclaimers straight off the bat, because I am using screen recording software known as OBS, the result's going to be that it will massively hamper read and write speeds on this PC. So we are not, I repeat, not looking too much at the read and write. I put them there on screen to show the detrimental effects. However, the actual read and write performance threshold is going to be massively bottlenecked because we are activating many things on this PC at once with regards to disk activity. So do not, I repeat, do not go by the read and write speeds as an indication of this disk. This is not indicative of these disks being used in real world scenarios. The reason I've gone for this level of test is I've gone for two scenarios, the same scenario on each with and without the heatsink, that show very small files at 256 megabyte, which is actually still quite small. And I'm constantly bombarding this Samsung 980 Pro with read and write activity of this file type. This little CAV file, a quarter of a gigabyte, and it's going to be repeatedly hammering this disk with this file here. Now remember, the sequential read and write that have been reported and expected minimum for the likes of PC gamers and console gamers is much larger than this, and sequential read is bigger files than this. So what we're doing right now is a scenario where much smaller files are being constantly read and written from these disks, and the main indication here is to see how this disk interprets and is able to deal with the temperature rises with and without a heatsink. So let's go ahead and begin these tests and talk over what we see here on screen. Because one of the earliest things that should become clear to you while you're watching this spin is the temperature rise on both sides of them will be very similar early doors. But the one without the heatsink, as you might expect, is already rising in temperature quite notably, very quickly, and a great deal faster. Those temperature rises are going to happen on the disk with the heatsink. It's impossible to avoid. But this is about sustained activity on these drives. Now, if you're using large open world games, if you're running games on online servers that are massive multiplayer experiences, then sustained and constant activity is going to be a concern. As you can see on the right hand side of the screen, the non-heatsink SSD has already broken past that ideal 50C scenario there. And as we can see, the one with the heatsink is still living there at 44C. It's rising, of course it is rising, but once again, it's about sustained activity, and your console and your online, be it your PS5 or even if you're a PC gamer watching this, or even a video editor, sustained activity like this is not going to go on for more than about 20 to 30 seconds at a time at the very, very, very most. And then there'll be periods of idle activity where the SSD gets to cool down. And the key point here is the time between these sustained activities is where the dissipation of heat on that NVMe SSD inside your console or even your PC system is where it matters. It has to have time to cool down. And as you can see, the one on the left, after more than a minute to a minute and a half of activity, of heavy sustained activity, is still underneath that 50C mark there, whereas the one on the right has already broken into 60C. Now, when I perform these tests around about I believe, something like 10 minutes apart while cooling down the system and rebooting it with and without the heatsink, the temperature on the right hand side of the screen within approximately 2 to 2.5 minutes broke into the 70C and just kept rising. And it took close to 3 minutes in the end for the Samsung 980 Pro inside the heatsink equipped system to cross into that 50C on screen there. Whereas it took a long time. It took close to 5 to 6 minutes before it even broke into like 65, 66C. Whereas on the non-heatsink one, it went into 70 and then started going into those real detrimental effect areas. And you may have picked up that the read and write has already started becoming a great deal more disparate on the non-heatsink version there. The dips are bigger, the drops are larger, and that's because the controller inside is now changing its behavior because of the rising temperatures and starting to throttle itself internally. And again, it's very hard to indicate this while we're using screen recording software, but I hope this demonstration has really shown you the difference in sustained performance overall with and without a heatsink. Let's go back there to the camera. So there you go. That is the importance of heatsinks. It's not a choice. It shouldn't be a thing where you go, oh, maybe I can go without one. Ignore all of that. Just get one. They're not that expensive. You can pick them up for about $10 if you like. And if you spend a little bit more, you can get some of the chunkier ones for about $20 or $30 to go down that road. So if there's anything I want you to take from this video more than anything else, it is about sustained activity and long-running instances of when you're accessing SSDs, what it can do and the detrimental effects of heat on these SSDs. If you're going to get an SSD heatsink for your PS5, ones like the Elegant or some of the other ones mentioned in the link in the description, I've updated them quite frequently this week, will give you some idea about some of the more compact ones you can go for. Alternatively, you can go for beefier, gamer class ones that will do a much better job of dissipating heat long term. And if you think your PlayStation is going to be on for extended hours and hours and hours and hours of time, or you're doing online gaming, or you're an esports player, I would heavily recommend more enterprise level heatsink. Other than that, once again, avoid these ones. Avoid these ones with the bands. They're only going to be a problem later on. And even if they don't snap, I do believe that the dissipation of heat on these is nowhere near of the same quality and standard as the other ones we have talked about. So do bear that in mind. But thank you so much for watching. If you've enjoyed this video, click like. If you want to learn more, click subscribe. Click the bell for notifications where we will be doing more PS5 content this week, where we're focusing squarely on this because I think not enough people know about this kind of storage. And it's a new world for some people, and it's great to be fully informed. Thank you so much for watching, and I shall see you on the next video.